So welcome to Everyday Mathematics. Today we are still on the 2023 University of Florida Integration B qualifying exam or qualifying round, problem number 24. And the problem looks as follows. The definite integral from x equals to 0 to x into infinity of cosine of the square root of 4046 x times e to the power negative x squared over 2. So this is an interesting problem. It involves a combination of a look into the complex manifold, but also there is some knowledge of the Gaussian integral that is required here. Now here at Everyday Mathematics, what we do is we go about and around and look at interesting problems. We try to solve them. We come back and share with you our version of the solution. If this is your first time to be with us, please, we do encourage you to consider subscribing to our channel. Your support would go a long way in increasing the profile of this channel. So let's move ahead and see how we may be able to solve this problem. So this problem here is interesting, and we'd like to focus on this part here, the cosine square root of 4046 x. Let's use Euler's formula, where cosine of x could be expressed as e to the power ix plus e to the power negative ix over 2, where I is the imaginary unit, or the square root of negative 1. So if we go ahead and plug that into our integral, this is what we get, right? It's obvious that one may want to just pull out this half out as a constant, and so we could also separate this into two separate integrals. Now we've multiplied e to the power negative x squared over 2 across. So now we have two integrals, and somehow we see a polynomial taking shape in the exponent position of e, right? So what do we do next? I would like to express this as a binomial expansion. And so first I pulled out the negative a half on both the integrals. And then what we see here is this is the same as for the first part, e to the power negative a half x minus I times the square root of 4046 squared minus 2023, because this we're trying to remove what comes from squaring the this second constant part here. And the same thing we've done on the second integral here, right? So this is just something that would come up. We said, okay, what is x squared plus, for example, 2bx, right? This would be the same as x plus b squared minus b squared. We're trying to remove the b squared out, okay? So that now we have a constant that we can pull out. And so we pulled out e to the power negative 2023. And so we do have a square here. I would use this first integral just as an example, where we could just say that let u be equal x minus the square I square root of 4046, such that du dx is the same as 1, and so du can be used to substitute for dx. But as we see, when x equals to 0, what happens is u is equals to 0 minus I square root of 4046, and as x tends to infinity, u tends to infinity minus I square root of 4046. So you would apply the same process for this second integral without losing any generality. So eventually we can see we've substituted our limits accordingly, and then we do have u squared here, and then y. We decided to use y for the second integral. Now I don't really like half in the exponent position there, so I could say let u prime be equal to u over square root of 2, such that what happens is du prime or du is 1 over square root of 2, and therefore we can substitute for du with square root of 2 du prime, right? And so what happens is, you see, we've done the same, and the limits are adjusted accordingly. Also, as you can see here, we brought this constant out. Same for here. So one may wonder, yuck, there's a lot of the I in the limits. Oh, this is intimidating. But this is easy. If you've done contour integrals, or you've done complex integrals, this would be easy peasy. So let's assume we have the complex axis, imaginary and real, right? And then we see that our contour for the first integral is at negative square root 4046 over 2, and from that point all the way to infinity. So if our contour of integral is c, then we could also say the alternative contour for the integration would be c1, which would mean that we go back to the origin, and then at the origin would go all the way to infinity, and then from there we drop down using c3. But we can see that, okay, c3 in terms of the magnitude is just the same as negative c1. So in other words, those two integrals cancel each other, and the effective integral really just remains as c2. So it's the same as just integrating on the real axis from 0 to infinity, right? And so we've reduced our integral that way. And for those of you who know Gaussian integral, integral from 0 or from negative infinity to positive infinity of e to the power negative x squared is the same as square root of pi. But then if you're starting from 0, since there's symmetry there, that's the same as square root of pi over 2. So that means that we have square root of pi over 2, square root of pi over 2. For those, since we have half here, when you add it, it becomes, okay, we've decided to multiply with square root of 2, So when you add that, you get e to the power negative 2023 times the square root of pi over 2. So our problem that we had initially, which was the cosine of 4000, cosine of square root of 4046 x times e to the power negative x squared over 2, that integrated from 0 to infinity, is equal to e to the power negative 2023 times the square root of pi over 2. Now I hope we've really explained this. This is one of those problems that can easily trip, and I mean, one can also get lost in integrating in the complex side of things using contours and all that, but we try to explain it as easily as we could. If you have any question, please don't hesitate to reach out to us. But it's been an absolute pleasure, really, sharing this problem and solution with you. Until next time, be blessed. If you haven't subscribed, please leave that subscription. Also, you could leave a like. Until next time, bye-bye.